The binary gear is a device designed to bring back multiple gear ratios to mountain bikes and gravel bikes, without the need for a front derailleur. It is manufactured by Italian bicycle tech company Magnetically, and is currently the subject of a Kickstarter campaign. The device replaces a bike's existing bottom bracket and features a 2-speed mechanical gearbox. One speed maintains a 1:1 ratio between crank and chainring revolutions, while the other speed increases the ratio to 1:1.25, making the chainring revolve 25% faster than the cranks. Riders can switch between the two speeds using a cable-linked handlebar-mounted lever. The binary gear is compatible with bicycles that have a PF46 or T47 type bottom bracket. The system comes with adjustable length cranks and is approximately 500 grams, 18 ounces, heavier than a conventional bottom bracket. By using the binary gear, riders can switch to a smaller chainring, smaller cassette cogs, and a shorter chain, reducing the overall weight of the bike. The Kickstarter pledge for the binary gear is €267, $288, and the planned retail price is €890, $960. Classified Cycling's PowerShift system, incorporating a 2-speed rear wheel hub, is another option for those interested in multiple gear ratios without a front derailleur. Acacia, a startup based in New Jersey, has developed the Space Acacia camping system, which combines a tent, tarp, and air mattress into one setup. The system features a pop-up tent made of waterproof coated Oxford cloth with fiberglass poles, 8 zippered screen windows, and mesh pockets for storage. It can also accommodate an optional air conditioning unit. The roll-out canopy, made of waterproof and UV-blocking Oxford cloth, extends from the tent's eaves and can be used to regulate temperature. It allows warm air to escape in hot weather and provides extra insulation in cold weather. The inflatable floor is constructed with 4-ply PVC and can withstand a load of over 4,000 pounds, 1,814 kilograms, without popping. It comes with a soft carpet covering and can float on water. The Space Acacia system is available in standard and XL sizes, accommodating 2 to 3 people and up to 6 people, respectively. It is currently being crowdfunded on Indiegogo, with prices ranging from $999 to $1,149. The planned retail prices are $1,236 and $1,437, respectively. Slovakian company Georgia Drilling has developed Enchorbit and Plasmabit technologies to enable faster and cheaper drilling for geothermal power generation. Geothermal energy, which harnesses heat from deep underground, is a reliable and clean energy source available 24/7, but accessing it requires drilling through hard rock. Georgia Drilling's Enchorbit technology uses a walking anchor system with collar sections and extendable pistons to stabilize the drill bit, increase drilling speed, and double the lifespan of drill bits. The Plasmabit system, connected to a standard drilling rig, utilizes pulse plasma drilling to crack and weaken rock using ionized gas and high-pressure water, enabling deeper and cheaper drilling down to 10 kilometers, 6.2 miles, underground. Going beyond 10 kilometers requires more advanced technology, such as Quasar's gyrotrons, to reach temperatures over 500 degrees centigrade, 932 degrees Fahrenheit, and extract more energy from supercritical fluids. Georgia Drilling recently conducted a public demonstration of the Enchorbit system, marking a significant step toward expanding geothermal projects and making geothermal power more accessible worldwide. The successful implementation of these technologies could greatly contribute to global energy production and the goal of achieving zero carbon emissions by 2050. PLP Architects in the UK is developing a fungus-based modular block as a renewable and biodegradable building material. The project is part of PLP's transition to symbiotecture, which focuses on biodegradability, non-polluting materials, and renewable energy in construction. The research group PLP Labs has been studying the structural capabilities and architectural potential of mycelium biocomposites. Mycelium, the root-like structure of fungi, has been recognized as a sustainable alternative in construction, with applications such as filling cracks and insulating houses. PLP Labs 3D printed a wood formwork and injected it with mycelium substrate, allowing the mycelium to colonize and create a moldable form. The mycelium is then dried using heat, resulting in a biocomposite material that is lightweight, fire-resistant, renewable, and biodegradable. The modular blocks made from bonded mycelium and 3D printed wood can be assembled into various structures like partitions, seating, planters, and tables. The use of mycelium biocomposites contributes to achieving a zero-carbon built environment and reducing global carbon dioxide emissions from buildings and infrastructure materials. PLP Labs plans to continue experimenting with mycelium biocomposites and aims to develop a D-kit for individuals to create their own mycelium blocks at home. A Caltech team has achieved the world's first space-based wireless power transmission, beaming detectable levels of power from orbit to Earth. The Space Solar Power Project, SSPP, aims to harness clean energy resources by deploying solar arrays in space. Space-based solar has advantages over Earth-based solar, including uninterrupted sunlight and higher solar potential per square meter. The Caltech team is working on a modular array system that can unfurl into large squares with solar cells on one side and wireless power transmitters on the other. The project faces challenges, including the cost of space launches and the predicted levelized cost of energy, being higher than retail electricity prices. The project received over $100 million in donations and has completed the first phase of orbital prototype testing. The testing involved modules for design and deployment mechanisms, solar cell evaluation, and wireless power beaming technology. The team successfully demonstrated wireless energy transfer in space using flexible lightweight structures and integrated circuits. The power beam was directed to a receiver unit on Earth, confirming the team's ability to target a power beam over long distances. The project envisions a constellation of sail-like solar panels in space that can send energy to remote regions and areas in need. Researchers have developed a magnetically controlled capsule for endoscopy that can be maneuvered using joysticks. Traditional endoscopy involves a long tube with a camera passed through the mouth, but the new capsule provides a less invasive alternative. Capsule endoscopy using a pill cam has been used since the early 2000s, but it relies on natural gut motility and gravity and cannot be guided to specific areas of interest. The magnetically controlled capsule endoscopy, MCE, developed by George Washington University, uses magnets to control its movement. The MCE was tested on 40 adult patients who required an endoscopic procedure, and it successfully visualized all anatomical areas of the stomach, with a 95% rate of visualization. The capsule is controlled by joysticks, and it provides continuous video and still images of bleeding, inflammation, or malignant lesions. The videos can be transmitted off-site for review by a gastroenterologist if one is not present during the procedure. The new method did not miss any high-risk lesions, and 80% of patients preferred it over traditional endoscopy. The researchers are developing software to enable AI-driven movement of the capsule and are planning to test it on a larger sample group. While the MCE cannot take biopsies like traditional endoscopy, it could be used as a first-line method for diagnosing gastric problems, with biopsies taken only when necessary. MCE has the potential to be cost-effective and reduce hospital admissions, anesthesia requirements, and missed workdays. DARPA is working on a super-silent submarine drive inspired by the fictional technology in the movie The Hunt for Red October. The technology is called magnetohydrodynamics, MHD, and involves accelerating an electrically charged fluid using an electromagnetic field to generate thrust. MHD drives have the potential to make submarines stealthier by reducing noise and interference with sonar systems. The main challenges in implementing MHD drives in submarines are developing powerful yet lightweight electromagnetic coils, and finding suitable electrode materials that can withstand corrosion and wear. DARPA has initiated the Principles of Undersea Magnetohydrodynamic Pump program to address these challenges and create a practical military MHD drive. Advances in magnet technology, specifically rare earth barium copper oxide, REBCO, magnets, have the potential to significantly improve the efficiency of MHD drives. Overcoming the issue of gas bubble formation on electrode surfaces and its impact on efficiency and electrode damage is a key focus of the research. DARPA is seeking expertise from various fields